All right, hello, if anybody's watching this video from State FFA, this is, we have a little bit to do on example 6. You guys yesterday were supposed to have calculated T, which is 2.6, or 2.26, and now we've just got to come up with the conclusion. So we're like almost done with the notes. Then we're going to bump over to the homework, and I'm going to show you how to find the R value, not by using the icky formulas, by having the computer do it for you. So I'm going to have you guys get your Chromebooks out, type in the Google Sheet, all that good stuff, and run it from there. All right, so here we are. We are to this point where we have our hypothesis. Let me go through that again. For some reason, you know how like when we do our hypothesis testing and we talk about like averages, X bar is for the sample, right? And then mu is what we use for the H naught and H1, right? Okay, for this, the number that we use in the sample is the R value, but the number that we use for the value that we use for the hypothesis testing is called P here instead, okay? So it's called a P value, but that really means like R, okay? R lives somewhere between -1 and 1, okay? And 0 is a bad R, and -1 and 1 is a good R. So this is good, okay? We have to convert our R to a value of T, and then that tells us where we're at on our bell curve. So if you haven't drawn a bell curve on example 6, do it. We're going to label him. Significance level is 0.05, and we're going to split him. So he's 2.5% and 2.5%, okay, which means 95% in the middle, all right? Now, the only thing that you guys have to look up from the chart, that little skinny chart, this one right here, is you need to know what N is, and you need to know which significance level you are. So 0.05 versus 0.01. We are at 0.05. We go down to our, what is our N?
Not a clue.
Not a clue? We've been doing the same data the whole time through, and I think there's 5, right? 5. Chocolate and Nobel Prize stuff, okay? So if we look at that 0.878 and -0.878. Okay, so here's the deal. 2.26 is the number that we calculated from the T, and we have to figure out where he lives in comparison to there. He is all the way on the right side, which means this one gets crossed off. Yes, they are correlated. So according to the data that we have, there is some sort of correlation, some weird correlation between chocolate consumption and Nobel Prize winning. So according to this, the data just so happens to show us that the more chocolate you eat, the more likely you are to do whatever Nobel Prize thing it is. Now, does that mean that eating chocolate causes that to happen?
No.
No, just because they're correlated doesn't necessarily mean that they are related to each other. I think you had a question like that on your homework, right? Okay, so according to this, yes, they are correlated. Got it? Makes sense? Okay, so that is our conclusion. The bottom one always means yes correlation, because we don't know correlation is where 0 lives, right? That's a bad linear correlation. A good correlation lives on the outside, right? So if it lives over here or over here, that's considered to be a good correlation. Got it? If it's in the middle, that's a bad correlation because it's close to 0. Make sense? Okay, so that's how that works. I think that for the majority of your homework problems, they just have P equal to and not equal to instead of less than, greater than. I don't think it tells you less than, greater than in most of these, okay? So let's bump over to your homework assignment. I told you to, for number 4, to finish this stuff, okay? All right, let's see. Do they tell you, 54 wild bears, okay? Let's go ahead and go through number 4. 54 wild bears. That means N is 54. You had to kind of like search for that word, right? N is 54. Now, they give you all the information you need in the next couple problems. You'll have to calculate it yourself. But our R value, our correlation coefficient R, this is from, our sample data is 0.96. Then they say that this is the critical value, okay? Now, if I'm looking for the critical value on this chart, that's where the critical value comes from, is from the chart, okay? I'm looking at 54, and I'm looking at a significance level of 0.05, and it does not give me that number. Because on this chart, it only goes to 50, right? Do you see 50 and then go over to 0.05? It's 0.279. They got 0.268. Okay, and the reason why they got that, the reason why that is different is because they used 54 and they used like the computer system to find the value, because ours doesn't go up to 54. Does that make sense? Okay, ours only goes to 50. Okay, so we're going to use their number because their number is technically more accurate. But for everything else, we'll just use this chart because I'm not going to make you go to the nearest, like, whatever. That's just why there's a discrepancy between this one and that one. Make sense? That is where the chart value is, where you mark here and here. So they said 0.268 and negative 0.268. Okay, let's finish this out and see what we get. Our hypothesis is P equals 0, and then is it equal to or not equal to? Or greater than or less than or whatever? Not equal to, I think it just says. Now, do you think that there is a correlation between, what are we talking about here? Between weights of bears and chest size of bears. Do you think those things are related to each other? Like the bigger the bear, the bigger the chest size. I'm going to say that they are related, okay? Which one are we going to circle if they are related? The bottom one. This means yes correlation, right? Always yes correlation, because zero correlation would mean no correlation, right? So I'm going to guess we're going to cross off the top and circle the bottom. We're going to see what that is, because I think those two things are probably related, weights and chest sizes of bears. All right, so let's go down here. You should have calculated a T value, okay? The formula for T, I got to write that down. Let me see. What's the formula for T? I don't know this. T, right here, is R square root 1 minus R squared over N minus 2. Okay, let's fill it in. What's the R value that we use? They give it to us. 0.96413. Right, from here, they give us that R. Okay, then we go down, 0.964137 squared, and then N, what was the N again? 54. Okay, when you calculate all that stuff, what do you get for a T value? 26.195. Holy cow, 26.195. That's a huge value of T. Where does he live? Way like all the way over there, right? All the way over there. Okay, now really, our R value, what's the maximum that our R value could be? 1. 0.96 is a pretty decent R. That's going to probably say that they are related. And in fact, that's a really good R, because our T value is all the way over to the right side. Does that make sense? Okay. So because of that, we're crossing this guy off because he doesn't live in here. He lives on the outside. And we're going to say, yes, they are correlated. Does that make sense? Okay. So when you're doing your like results, you can say reject H naught. But instead of saying like claim true or false, I would say like yes, correlation. They are correlated, right? Like there is a relationship between the two variables that we're talking about. All right, let's go back through and make sure we answered all the questions. Is there sufficient evidence to support the claim that there is a linear correlation? Yes, they're correlated. If so, does it appear that a measured chest size can be used to predict weight? Probably, because they are correlated, so we could come up with a formula, and that's exactly what we're going to do in section 10.2. We're going to use the formula to spit out the different values, okay? So does it appear that measured chest size can be used to predict weight? Yes. Can use chest size to predict weight. Okay, it won't be exactly the same, but it'll give us a pretty good idea of like how big that bear is. If you tell me the chest size, I can pretty well tell you how much that bear weighed, right? Okay, not in all cases, right? Like sometimes you'll have people with the same like chest size up here, but then they got a big old belly on them, like me. I might have the same chest size as somebody else, but obviously like my lower half is a little bit bigger, and so we're not gonna be the same, right? What?
You and
Me and Mr. Streff would be like right straight on, right? Like we would be exactly the same. But anyway, everybody else, I'm gonna
you
like
might be a little bigger.
My chest size is gonna say that I should weigh a lot less than I do right now because I have a big old belly on me.
Big belly.
So there's that. Okay? Good on that? You're going to skip example 5. Go to like example 6. You have 6, 7, and 8. And 6, 7, and 8 don't give you the value of R like they did in number 4.
Is that tornado? I have to go home.
Or a fire. They're testing it today.
Oh, that's so boring here.
Well,
no, did you actually know? I was ready to go home.
They won't pull the siren for that.
Yeah, they would, Jake. It's you know there is. It's literally
Does Blue Hill ring the bell at like 6 or like ring the siren at like 6 o'clock like sometimes? Bladen does that, but Lawrence doesn't.
They
The
do
only
it
time
on every
ours
Saturday
they
of
do
the
it
month.
at what time?
12. It's like 10.
Ours is at
9,
10:30.
12,
10:30 every Saturday, whatever, and we always
First
get a
Saturday
page.
of the month.
First Saturday of the month. Yeah. They call and ask. Oh, really? They do. Interesting. I always wondered who they called. Interesting.
In the sky. Duh.
They always send us a page, like, so I have a pager at home, and they always send us a page saying they're testing the sirens at 10:30, and I'm like, yes, of course they are, like they do every first Saturday of the month. They always page us.
Your pager reaches that far?
What?
When I leave work, my pager doesn't work anymore.
Well, it's when I'm at home. I leave my pager at home, but I get all my pages to my phone too. So if a page goes off, it goes to my phone. So,
Interesting.
anyway. All right, so you have 3 on the back side. You have to calculate the R value yourself. No. Okay, let's talk about how you do it. We'll calculate the R value together on number 6. How about that?
Our computers for anything? No,
What?
let's not do that.
Yes, you need a
Can I
computer
pull out
for
my
this
water?
right here. Okay. All right, so you're not going to be able to see this on the video, I don't think, because I don't think I'm in the right recording. But anyway, go to a Google Sheet. This is my Google Sheet that I have from the other day. And I'm going to delete out all of these values right here. Whoop. And we're going to type in, so I have no data on my graph, right? I'm going to type in these numbers. So if you want to practice doing this, it wouldn't be a bad idea. 80.6, because you're going to have to do it for your homework. 68.4, 79.4, and 38.3, I think. Now, look at the magic that happens. As soon as I type in the first one, it's like, whoop, you have something. There it goes. 8.6, 3.2, 1.7, 10.8, and 0.1. Okay, so is all my stuff in there?
Your nose into your sleeve.
I don't even know my nose. Look at this.
What?
It's right here. What are we looking at? Doesn't it look bad?
Okay.
It's right here.
You're the only one that knows.
Nobody thinks
All right, so there's that.
What are we doing?
This is what my chart looks like after I type all those numbers in, and I have a chart inserted. Do you remember where you go to? Let's see. Do you remember where you go to get the equation? You go to customize. Oh, you go to series first. No, you go to customize first, then you go to series. Then, to get the equation that you need, you go down to label, and you say use the equation, and then show R squared. Okay, that's where you're going to find on your Google Sheet. Okay? So, according to this,
So R squared.
R squared equals 0.642 is what I got for an R squared value. Let me go back. Okay, 0.642 is R squared. How do I get just R? Take the square root of 0.642. Somebody on your calculator, take the square root of 0.642. Somebody got it?
No.
Take the square root of 0.642.
0.801.
0.801. Okay, that is what R is. And then you also need N. What is N? 6. 6. What? Okay, you're going to use the chart to find these guys. Okay? And then you need to calculate what T is. T is that formula. R over. You got all the stuff you need. Square root of 1 minus R squared over N minus 2. There you go. Calculate your T. Figure out from your chart where these go. Figure out where he lives. Fill in your H naught and H1 and then answer the questions. That's all you have to do. Okay? So you will need your computer to calculate the R's for each one of these. Okay? Got it?
Are they all going to be not equal to?
Yes, I think they're all not equal to. Okay? Good?
Oh my.
Happy with that? All right, there you go. Goodbye.